Alright guys, welcome to another session. We're going to be today covering how to write or understand nucleic symbols. And from these nucleic symbols, we're going to be able to tell the number of protons, electrons, and neutrons. We'll also go over mass number and atomic number and what those mean. So basically in this video, you need to understand and have a good understanding of isotopes. So let's go ahead and get started. Now, let me go ahead and show you some things that you'll need. You'll need a periodic table, and if you don't have one, you can download one from my website, from whitwillhigh.com. My name is Johnny Cantrell. Um, that's where you click on Teachers. Also, um, let's let me show you some of the problems that I'm talking about. Okay, what type or what is a nucleic symbol, and what types of things we're going to see. Basically, a nucleic symbol is something like you see here. Atomic notation. Here you have A, which is noted as the atomic mass, meaning the mass number, and Z, which is the atomic number. So your mass number is the number of protons and your number of neutrons. Z is just your number of protons, and X is the element. Now, normally if you have a charge, it will appear to the top right, okay, on the right side of the letter X. Remember, this big letter X is the symbol for the element that we're going over, okay? So that's what a nucleic symbol is, atomic notation, whichever one you prefer to call it. Now, let me go ahead and present a problem to us so we can go ahead and get started. So let's look at this webcam right here. I'll take a sheet of paper and I'll show you one. Let me full screen this. Once again, I'm using Ubuntu 9.10 to make this video, and I'm using my webcam, of course. Now, normally what they'll do is they'll give you an element. Say they give you iron, okay? So the symbol for iron is Fe. And what they'll do is they will find an isotope of iron. So let's find where iron is on the periodic table. Now on the periodic table you see the element, Fe. You also will see 26. The 26 stands for the number of protons. Now this down here, the 55.85 that you see here, is the atomic weight, often referred to as the atomic mass. Now it's not the mass number. Now basically it's an average of all the isotopes. Okay, pretty much. Okay, that's what the atomic weight is. So basically 1 mole of iron is 55.85. So let's go ahead and say that we're talking about isotope of iron, say 56. So if we were talking about isotope 56, notice that there is no 56 iron on here. This is really close though. Okay, so basically, let me pull up the webcam. So basically, if they tell you that they are dealing with isotope 56 of iron, they would have a 56 here. Sometimes they do not tell you the proton number here, the number of protons, which is also the atomic number. They don't tell you this here because they want you to find the element on the periodic table, which we will right here. Notice it is the 26th element. So that 26th element tells you that there are 26 protons. Okay. Now on this one, we'll pretend that there is no charge. Okay. So basically, they may ask a series of questions. How many protons do you have? Well, you have 26 protons. They may ask another question. How many neutrons do you have? Okay, the N stands for neutrons. The 0 here stands for no charge. Neutrons would be 56 minus 26, which is, you guessed it, 30. Now, this is the one that a lot of people seem to have trouble with, the electrons. Now, if they do not show you a number here, okay, a charge, then you are to automatically know that the number of protons and the number of electrons must be equal. So if there are 26 protons and there is no charge here, then there must be 26 electrons. Now that's all she wrote on that problem. Now let's pretend that we were dealing with a cation of iron. Okay, same isotope of iron, say 56, and you know this is 26, you know this is Fe. Well, one of the isotopes, one of the cations of iron is iron 2 and iron 3. That's two of them. So let's deal with, say, iron 3. Iron 3 is a +3 charge. Now, here's what's nice about this. Even though this is a cation, you know, meaning a positive charge, you will still have the same number of protons. The proton number will never change. If you change the proton number, you change the element. Okay, so that number is still 26. The neutron number is still, in this case, 56 minus 26 is 30. Still 30. The only thing that's going to change is the number of electrons. Now, in order for this to be a positive 3 charge, we had to throw away 3 electrons. So, we would write 23 down for the number of electrons. Now, if you're wanting to know how I got that, other than me just telling you to throw away, basically what you do is you take the number, to get the number of electrons, you will take the number of protons and subtract the charge. Okay, so let's deal with something that is, say, negatively charged. Let's say that we're dealing with, let's pick something that's negatively charged. Chlorine is negatively charged. It's a -1 charge. When it forms as an anion, that's an ion with a negative charge. So let's go ahead and pretend that we have it. So let's assume that we have Cl for chlorine. And notice here it's 35.45. Well, let's pretend that we're dealing with chlorine, say 30, I don't know, 35. Why not? Say 35. Okay. So we're dealing with chlorine 35 isotope. And we know it has 17 protons. So far we're dealing with this. This is what I've written down. I got the 35 from basically out of thin air, just pretending that there is a isotope 35 of chlorine. I don't want to break out a CRC somewhere. And I know that there's 17 protons because on the periodic table chlorine is the 17th element. So that's where the 17 comes from. Now we're going to pretend that this one has a charge. The charge here is -1. Well, believe it or not, the number of protons is how many? Yes, you guessed it. It is 17. The number of neutrons? Well, what's 35 minus 17? Well, 17 is 34, so it must be 18. Because 35 minus 17 is 18. Now the number of electrons, let's think about this. The number of electrons here is going to be this charge. It's -1, meaning it's got one more electron than it does protons. So the number of electrons in this one is what? Is it 16 or is it 18? Well, if you guessed 18, you would be correct, because there's one more electron than there are protons. Now, as far as your atomic number, what they'll use is the letter Z on these. So the atomic number of iron, which just means the number of protons, is 26. If they ever ask you for the mass number, they're just wanting to know this top number up here, which is 56. Same thing on this one, you know, because the problem's pretty much almost identical. Okay, you know, because I got those numbers from there as well. And on this one, the atomic number, which is Z, is 17, and the mass number is 35. Alright guys, well, I hope this video was helpful. You just need to make sure that you remember that A is the mass number and that Z is the atomic number. And really, I think that's the only thing that's difficult, other than remembering that to get the number of electrons, it's the number of protons minus the charge. Anyway guys, I hope the video was helpful. I hope you enjoy it. So the only thing that's left now is the credits. So let me go ahead and bring that up, and y'all try to have a good day and don't work too hard, too long on the problems. I don't want you to go crazy. Alright guys.